All right. But let's start today's session. So, today we are going to discuss injections, and these are part of a series called um, Securing Rails Applications. So, let me share my screen. All right. So, today we will be looking into injections and what are injections and how we can avoid those. So first of all, let's see what injections are. So injections basically is a class of attack that introduce malicious code or parameter into web application in order to run it within its security context. So injections are a bit tricky because same parameters or context can be like um, harmful for one context, and it can be totally fine with other contexts. Like in Rails application, we should prefer using except instead of only for security related actions. For example, if we are trying to find authenticate a user or adding authentication on multiple methods, we should use except instead of only, because if you use only, there might be chances if you add new methods later on in the code base, you forget to add those method in security checks. So always try to use except, so that you don't really forget to add anything to security checks. It will be added by default. It will only skip those methods that are in basically permitted lists. So to avoid cross-site scripting, don't try to correct user input using restricted list. For example, you can see here is a list. Here is an input from user. We will see what cross-site scripting is in detail. But if you look at this example on screen, we have this user input, and if we try to correct this input using gsub, basically we are using a restricted list to correct some user input, which is dangerous because imagine if a user input something like um, what's on the screen in orange, and if you remove script with this empty space, the script tag will work again. So that can be harmful, and that might not be what we intend to do. So um, that's why I'm saying permitting lists are always preferable. So if you find any user input that is basically not correct, completely reject that. Don't try to fix it. So that's one thing we can do to avoid injections, by using permitted list over restricted list. Um, so what basically are SQL injections? SQL injection attacks aims at influencing database queries by manipulating web application parameters. So, by definition, it is pretty clear that these attacks basically aim to get access to database and the data within. So thanks to clever methods in Ruby, we don't really have this problem in Rails applications. So but these are quite common attacks, so it is very important to learn how to prevent these and what the actual problem is. So common goals of a simple SQL injection are basically bypassing the authorization and carry out data manipulation or reading arbitrary data. So these are two common goals that are behind an SQL injection attack. Bypassing authorization basically means whenever a user try to add credentials from login page, um, an application usually try to find a record from database. If everything matches, application basically allow that user to access the web page. So by passing that process is one common goal of SQL injections. So um, we will see how an attacker might bypass the authorization. The other common goal is to read unauthorized data. So in SQL, there is a query called union. It is a statement and a keyword, SQL keyword basically. We attackers can use this SQL keyword to basically read unauthorized data. We'll see that how it happens shortly. So let's see some example of SQL injections. So if you look at your screen, how not to use user input data in queries. So basically, whenever you write where clauses for any particular model, there are ways that we should not write those queries. So for example, if you write project where name and directly pass parameters to this string by string manipulation or string, so this is basically harmful. Imagine if this parameter consists of this particular text or one dash dash. This dash dash basically means it is anything um, beyond this point will be considered as comments. So this query, which should return all the projects matching with this particular name, will be returning something else. For example, the above uh, query can be like select static from projects where name equals to empty, because we are passing, because an attacker might pass this as a param. So we are closing this string and or passing one and then commenting out the rest of the query, which means this query will return every project because it is adding an or statement with a true flag. So query will become like select static from projects where name equals to empty or true. So wherever the project has a name, that will be returned by this query. So we should always avoid passing direct parameters to query. We should always sanitize them. How we will do that, we'll see in next slides. But let's see another example of bypassing authorization. So let's imagine we have a login method where we find user by find by method and pass login name and password directly into the string without any sanitization or something like that. So if an attacker enters or 1 equals 1 as the name and or 2 is greater than 1 as the password, the resulting SQL query will be like select static from users where login is empty or 1 equals to 1. This will always be true because 1 is equal to 1, and password equals to empty or 2 is greater than 1. So password will be always true, so as 2 is always greater than 1, and limit the user by 1. So it will basically return the very first user and access, and the attacker can access the website or any data he wants that relates to that user. So you can see how attacker can bypass our authorization by simply if we are not careful with our code. So let's see another example of unauthorized reading. So for example, if you look at this query, this is the again same query, project where name equals to uh, param, getting name from a parameters. And now let's inject another query using union statement. So as I mentioned earlier, the union statement can be used to um, get access to unauthorized data. So for example, here if in the param name any attacker passed this particular text, the resulting query will become select static from projects where name is empty and union that with select id and login as name and password. as description 111 from users, and rest of the query will be commented out with these two dashes. So this the result won't be a list of projects because there is no project with an empty name, but a list of username and the password. So I hope because we are using device, our passwords are encrypted as well, so we are safe on that side. But this is how attackers can access username and password list from the entire database. The only problem for an attacker would be that the number of columns in union query should match the previous queries. That's why he is passing 111, which will always be true. So these columns will always match the first query, and the returning result um, will be name and password, username and password from the entire database. So you can also see he is renaming some of the columns, like id login as name and password as description, so that our web application doesn't think anything is wrong and display the data as needed, and everything is fine. The description and login will show username and password. So you can see how dangerous this could be in a production database if we are not too careful about writing our queries and allow directly passing parameters to different queries. So what we can do to avoid these? There are some countermeasures. Ruby on Rails has a built-in filter for special SQL characters, which will escape any quotation marks and null characters and a line break. If you see these previous examples, every time we are ending the input by adding this particular quotation mark. So Rails has built-in filters that can escape those, and also escape some null characters and line breaks as well. But the problem is some of the methods add these countermeasures automatically, but for some we have to do that manually. Um, let's see how we can do that. Using model.find or find by something automatically applies the countermeasure. These are the method that applies like countermeasures automatically, and they sanitize every input that you pass in. So these are safe to use. The SQL fragment, especially in conditions fragments, where like for example, where we have seen few example of you incorrect uses of where clause, and execute and find by SQL methods, it has to be applied manually, because they don't really apply countermeasures automatically. So we need to be careful about passing direct input from user into these particular methods. So the other thing we can do is, instead of passing a string, we can use positional headers to sanitize strings. For example, we can use question marks, and if we write queries like this and add question marks as placeholders, these will be automatically sanitized. Any HTML character or invalid character will be escaped automatically. So this entered zip code will be replaced by first question mark, and the entered quantity will be replaced by the second question mark. And this is very common practice we follow as well. So another thing we can do is we can use like symbols and name the parameters we are passing to any query. For example, here this zip will be replaced by values from this hash, and quantity will be replaced by value from this hash. So these will be sanitized automatically. And the other thing we can do is we can split where clauses into multiple where clauses and directly use hash syntax. So this is also sanitized. Where these countermeasures are not available, we can always use sanitize SQL method, to sanitize them manually. So next, we will look into cross-site scripting. So what cross-site scripting is? Cross-site scripting is the most widespread and one of the most devastating security vulnerabilities in web application. This attack basically injects client-side executable code, but the good news is Rails provides some helper methods to find these type of codes and prevents these type of attacks. So let's have a look how this works. Um, One of the common example of this particular attack is entry points. Entry points are basically very common. In this particular attack, sender sends an entry point for the target. For example, you have you might have seen some messages with different links and some comments on social media or anything where a user can input something. There might be a risk of entry point cross-site scripting attack. For example, if you look at this particular diagram, an attacker sends a message to some person with a risky link, and if a user clicks that link, there might be some script in that link, or there might be visible or some hidden headers that redirects the user um, to pages that attacker want. Basically, if that user clicks that link and do some payment, that payment will be transferred to attacker instead of the actual website. So this is pretty common example of entry point attack, and there are a lot more things to cross-site scripting than these entry point attacks. Most cross-site scripting example simply display an alert box, but it is more powerful than that. Cross-site scripting can steal cookies, hijack sessions, redirect the victim to fake websites, display advertisements for benefits of attackers. So it can change element on websites. It can get confidential information, and it can also install some malicious software on your system, so that um, attacker might can monitor whatever the user is doing. So this is a little bit about entry point attacks and cross-site scripting. So I think that's it for now. Any questions?